Okay, today we're going to review conics, and this will probably be a two-part lesson. This first part is going to be identifying conics by what you have in your question format. So when we talked about parabolas back with quadratics, we always had like x squared in our problem, and we had we had and can't think what I'm trying to say. We had our x squared in our problem, but we had other terms as well. Well, now we might have a squared term, but we're only going to have one square in our problem, but it could be a y squared or an x squared. Then we have a hyperbola. Hyperbola is a problem that has two parabolas. So for it to have two parabolas, it has to have two squares. But it has to have subtraction between them, and that's what makes them turn out away from each other. Then we have ellipse and circle. It has two squares that are added. So that doesn't make an ellipse and a circle different enough, but if you think about it, it's two parabolas that are meeting. The difference is the ellipse are longer one way than the other, and the circle's not. So this has two different coefficients to make it longer one way versus the other. So if you look at these questions, the first one has different numbers, addition with two squares. That makes it an ellipse. This one has same number with two squares in addition. That makes it a circle. This one has a subtraction with two squares, so that's why it's a hyperbola. And this only has one square, and that makes it a parabola. So parabola and hyperbola would be the first two I would look for, because hyperbolas have the subtraction between it, and parabolas only have one square. Then you can at least have narrowed it down to what you can find. So now stop the video and do the independent questions that go with this. I'm sure you do, because we spent a whole entire chapter on packets. All right. So how do I know when the problem is in what we call standard form, which conic it is? Well, look for the same things. How many squares you got? Two. Is it adding or subtracting between them? So that narrows it down to circle or ellipse. Are the numbers the same? No. Now what numbers am I asking about? Denominator. The denominator. So that makes it a... All right. Ellipse. Clips. That's funny. All right, ellipse. Now, let's talk about the key features of an ellipse. The first key feature is the center. The center is made by getting these numbers that are in the parentheses with the x and the y to show you the up, down, left, right motion. So if you have x minus 3, which way did you just shift? The right. That's right. And what does this plus 2 make me do? Left. Y's don't go left. Oh, down. Down, okay. It's got to do the opposite of what it's doing. So this is down 2, and that's right 3 because that's an x thought. So just think about what x's and y's do and do the opposite. So that makes your center the 3, negative 2. Does that make sense so far? Okay. Now when we graph this, we don't really know how far to make all of this over here. So if we put our xy axis in the middle, this point being in quadrant 4 might go off the graph some. So let's get a little bit more information and we'll see if it'll work in the center. So next, this is related to a value of A and B. Well, actually, wait a minute, I might have that backwards. But A is always based on the bigger number for ellipse, meaning that's going to be related to how wide it is. Now, these numbers down here have been squared, so you have to square root them to find A and B. And again, A is always off of the bigger one. So the bigger direction on this is going to make my y's go bigger than my x's. So from this center, I'll go out 3 up and down, and I'll go 2 across from the center, left and right, to get my ellipse shape. So that's not that big. But since I don't really need a lot of quadrant 2 to do that, I think I'll shift over some, so I can have more of quadrant 4. And I might even shift up some, because I can think about, do I need that? I think it'll work. We'll try it this way. All right. So think about when you're looking at these two numbers, you know, if you go right or left or up or down that amount, to make sure you got enough space around your center. So we plot our center over 3 down 2, and we put a C next to it to remind ourselves that's the center. Now the y values are going to go up and down 3 from that center. So up 3, that will be a vertices, and down 3, that'll be a vertices. Vertices are things that look like maxes or mins, right? So where are those 2 points?
3, 1.
Okay.
3, -1.
And 3, -5. Now if you've done that right, you can add 3 to the y value, and that does come out 1. And you can take 3 away from the y value, and it'll come out -5, and you'll know you did it right. Does that make sense? Okay, because this is a plus or minus value, and you change the y by that amount. Now we're going to do the same thing with the b value. We're going to count out 2 to the right and 2 to the left, and these are called co-vertices because they're not as important of vertices as the original ones that we got, because that's the longer direction. But they're just as important in graphing the parabolas together to make our ellipse, which is what this is making. So now I'm at 1, -2, and 5, -2. And if we did that right, you should be able to take your center on the x and add 2 and subtract 2 to get these 2 x values. And that does make sense because 3 minus 2 is 1 and 3 plus 2 is 5. So there's our ellipse on our graph. And again, the vertices are more important because it's longer that direction. Then the last part of a ellipse problem is called the foci. And the foci are really important points because if you built an apparatus that actually draws an ellipse, it's based on where these foci are. And if you, I can show you one of those apparatuses if we have time today, in terms of how it draws an ellipse. But I'll have to do it with a video because I can't do it with a board. So with the foci, there's a special formula that helps you to calculate how much to move from the center for your foci, and that formula is almost Pythagorean theorem. So when the problem has plus, it has minus, and when the problem has minus, it has plus, and it has the real Pythagorean theorem. And you only use this formula thought process on ellipse and hyperbola. The others don't use this formula. So I already know what these numbers squared are because they were in the original problem. So a squared is 9 and b squared is 4 because they were what it was before I square rooted them. Does that make sense?
Yes.
And so we subtract that and find out the square root of 5 is my c value. Now it's plus or minus the square root of 5 because I got to move out in both directions from the center. And how I know which way to move, if it's up and down or left or right, is move the longer way. See, A was under Y, so C has to be about Y. So that's why knowing that's A is important, because A and C have to be the same direction. Now the square root of 5 is a hair over 2. So we're going to go up 2 and just a hair more and put a dot, and that's one of my foci. And we're going to go down to, and just a hair past it, and put my other foci. Now, obviously, I don't want to write decimal points down, and that's where the plus or minus comes in. You take your center, 3, -2, and you decide if that's about y or x, and ours is about y, and you put it on the y value of the center. And you don't write 2 separate points unless you just really want to. We can write it as one big point with the plus or minus, and that shows both points. So those are all the key features of an ellipse. Is this coming back to y'all? Jacob, have you ever seen this before? Okay, you got a lot to learn then. Okay. All right, so we're going to look at the next one, and it's a totally different conic. I'm only showing one of each one today, so you can get the idea of how each formula works, and then you'll get to practice some. So this only has one square, so what does that make it? Parabola. Now this parabola, what's important to know about this parabola is whatever's the parentheses that's not squared has a lot to do with which way it's going to open. Because this over here is the not squared parentheses, it's all about x. And because the number in front is positive, it's going to open to the right. Now that's what you have to know. This is the variable, so that means it's going to either be this way or this way, but because this is positive, it tells me it's going to be this parabola. If it was next to y, I'd have to worry about up and down. It's the one that's not squared that tells you all the information. Now, in a parabola, there's technically not a center, but there is. The vertex is the center of a parabola because a parabola has a vertex with a focus inside and a directrix on one side of your vertex on the opposite side from the focus. So this is what we're going to try to draw for this particular problem, but I could turn it up, I could turn it right, or I could turn it down depending on what variable and what signs I have next to it. So my center, or what I call my vertex, the vertex in this question is the center. Well, we don't call it center, but it is the center of your graph. It is made by pulling this information out. Make sure you pull x out first because x isn't first in this problem. So x plus 2 is going to make my x -2, and y minus 1 is going to make my y value 1. Did I lose anybody in pulling that point out? Does that make sense to you, Jacob?
Yeah.
You just got to be careful because x is sometimes first in the problem, sometimes it's not. Parabola is the only one that x doesn't, and when a hyperbola, sometimes x isn't first either. All right, now I've got to learn how to calculate this foci. To calculate your foci, you take this 4 and you set 4c equal to that number. It's always 4c equals that number. The distance from the vertex to the foci, this distance right here is always c. So because of that, if we set 4c equal to that, we can solve for how long is that distance and is it a positive or negative direction. So c is equal to 1, and because it's all next to x, this 1's going to be to the right because it's all next to x. So since our foci is not very far away, I don't think we have a problem with putting it in the center this time, because we're going to have a really small graph. I didn't get mine too centered up, but that's okay. Still got plenty of room. All right, I'm going to plot my center, or what I call my vertex, -2, 1. Go over -2, up 1. Label it vertex. Probably should have put that V in a different place. Let me move that. All right, now we're going to move 1 to the right of it to get our focus. So 1 to the right would make it here. Instead of having foci, we have 1 focus. Foci is the plural of focus. So parabolas only have 1. And where's mine? That's right, -1, 1. The other part of our problem is called a directrix. A directrix is a vertical line that's on the opposite direction from where you were, or a horizontal line. Now, if you draw the arms of your parabola going around your focus, it'll help you to figure out if it's vertical or horizontal. Because your parabola should open up around your focus. It's kind of like a satellite dish. That big thing that sticks up in the middle of the satellite dish that receives it has to be at the focus of your parabola from your satellite dish. So the directrix is going to be in the opposite direction, and it's going to have to be in a direction so that it won't cross your parabola. So if I draw it horizontally, it'd cross my parabola. It won't cross my parabola if I draw it vertical. And that went through -3, so it's x equals -3. Now here's another clue on which way to draw it. This problem's all about x. Whatever changes here in your vertex to your focus, if the x changes, this has to be about x. And notice C was 1, so this one went up 1, and from -2 to -3 went down 1. Same concept. It's how far did it move. But this is a vertical line equation, not a point. All right. I think that's all there is to a parabola. It's pretty straightforward. All right. So our next one is circle. How do I know it's a circle? It's because it's got two squares, it's got addition, and they don't have different numbers under them. So this is a circle. This goes back to the formula. X squared plus y squared equals r squared, where HK stands for how much you moved it up, down, left, or right for the center. So my center is still going to be based on these numbers. Now you can see why we keep changing them to the opposite. H stands for the number that goes after the subtraction sign. It can't be 4 because it's supposed to be minus -4 that they changed to addition. It has to be what is it after a subtraction sign. And that's why we always make them the opposite. So this center is going to be -4, -3. Then all you have to do to find the radius is square root the number on the end of the formula. So the square root of 9 is 3. And that's pretty simple. Since -4, -3 is in quadrant 3, I think it would be behooving to us to put it a lot more quadrant 3, and maybe even a little bit more higher up than that, maybe more like that, so that we make sure that we have enough quadrant 3 to go out 3 in all directions. So we've got to plot our center at -4, -3. 2, 3, 4, 1, 2, 3. There's our center. To make a circle, you count up, down, left, and right, that radius. So I go up 3, I go to the left 3, I go to the right 3, and I go down 3. And I do my best to make a circle. And we don't have to list any vertices or co-vertices or foci or any of that on a circle. Circle is the simplest conic there is. Yeah, yay for simple, right? All right, hyperbola's got the most, so I left it for last. How do I know it's a hyperbola? Doesn't make any. Doesn't have anything to do with that. Yeah, it's all about the subtraction sign because they could be the same. No, you focus on things differently sometimes when you start noticing things like that. Very rarely do I ever see one alike, but they could be. All right, so our hyperbola is basically two parabolas. They're either both turned right and left, or they're both, one's going up and one's going down. Who's first tells you that. So this one starts with an X. That means they're both going to open to the right and to the left. If it started with a Y, they'd open up or down. So the first thing we need to do is find our center again. There's a center to every graph, except parabola, we call it vertex because it's in the center. So where is the center in this problem based on those parentheses? 1, 4. All right. Second thing, this is always about A on the first one because the first thing in a hyperbola is more important than what comes after the subtraction side. Because whatever's first is going to tell you which way it opens. So you want your A to be about which way it opens. So what's A?
Plus or minus 5.
Okay, plus or minus, you can write that in there or not. It's up to you. But you're right, it is plus or minus on each one because it tells you to go up and down or left and right. But even if you left the plus and minus off, as long as you got the 5 right, I'd be okay with that. Now, this problem has only a set of vertices. It does not have co-vertices. But we plot them anyway. But we don't list them. And I'll tell you why in a second. So we've got to be able to go up 5 and down 5 and left 4 and right 4. I think we're going to have a problem with up and down more. So I think we need to switch our x-axis just a line or two down to be able to get that up there. I think. Let me count that first before you draw that x-axis in. Let's see. 1, 4, 3, 4. 1, 2, 3, 4, 5. Yeah. 1, 4. Yeah. Yeah, that'll work. You just want to make sure you don't run out of space, y'all. Actually, I counted that the wrong direction. I'm supposed to be counting across. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, I got enough room. All right, so we're going to plot our center, and we're going to count this 5 out in an X direction. This is all about right or left. So 1, 4 over 1 up 4, put your center. Count 5 one way from that to the right. 1, 2, 3, 4. And 5 left. 1, 2, 3, 4, 5. Those are your vertices. Then we're going to count our fake co-vertices, but we're going to list these two vertices first. Wouldn't that mean both of them have a 4 in it? So we just got to figure out what the x value is, because they stayed on the horizontal line. What is that, -4, +4? And 6. And that makes sense if you think about it, because 1 minus 5 is -4, and 1 plus 5 is 6. And that's where writing that plus or minus can be helpful, because it reminds you to add and subtract it to the x value. Now, the B is for fake vertices. So we count 4 up and 4 down. 1, 2, 3, 4. 1, 2, 3, 4. And we don't label them, but we do plot them. Now, a hyperbola of this type looks like this. And they're going to be like these dotted lines that are called asymptotes that you can curve it to. To get those dotted lines in the right place, we put a fake rectangle in here. And the reason we put that fake rectangle in there is because then we can connect the diagonal.
Don't you just go straight through the center?
Yep. Your diagonals should go from the corner of the rectangles through your center. And having a ruler would really help on that a lot more. But it's okay if it's a little wacky looking. Now, why we do that is because those dotted lines are what the parabola curves to. You want to get close to it, but you don't want to touch it. So when you put your parabola in, you're just going to come up here and kind of go near it.
Once you touch the edge,
So vertices is the only piece it touches. And then you do the same thing on the other side. You curve it up. You curve it down. And it may not even cross the x-axis at the right place because we're hand doing this, and that's okay if it doesn't touch the x-axis in the right place, because we're basically just trying to do a rough sketch. It's not perfect. but it doesn't want to touch those lines. Okay. Now, we got to get our foci. That's our next piece. And then we're going to get where those lines are. Those are called asymptotes. All right. Foci are easy. Foci are based on Pythagorean theorem. A squared plus B squared equals C squared. Because this is minus, it has to have plus in the Pythagorean theorem, where the other one was the fake Pythagorean theorem with the subtraction sign. And we already know what they are squared. So this is 25 plus 16 equals C squared, which is 41, right?
Yeah.
So that's the square root of 41. What's the decimal for the square root of 41? 6 point something? Because 49 would be 7, so it'd be 6 point something. See how you don't even have to know 6 point what? Although knowing a little bit, you might could estimate a little better if you did. So about 6 point something. So we'll go over 1, 2, 3, 4, 5, 6 and put it in here. And we'll go over 1, 2, 3, 4, 5, 6 and put it a little bit over. And by the way, knowing the decimal part of that would make you get it in the box in the right place. You know, is it 6.2 or 6.9? We're just estimating right now, but you really should look at the decimal. I think it would be closer to being in the middle probably because of it being 41, but I don't know that. I'm just estimating in my head. Now who gets it, X or Y? The X. So we put 1 plus or minus the square root of 41, 4. Because this is plus or minus, when you take a square root, it's always plus or minus. And that makes your two foci, one with plus and one with minus. And then the last thing about this is asymptotes. And with asymptotes, you use the point slope formula. Y minus y1 equals m times x minus x1. These two, x1, y1, is the original point because you count it out from the center. The slope, you count rise over run from the center. So that's not hard to get. How I like to do it is I like to come over here and think about counting up and to the right corner, because then I can always say I'm counting up and over, and if something comes out to be, you know, easy to count, all positive, that kind of thought. But some students go back and look at the original problem. Now tell me what that is if you count up from the center and to the right to the corner. 4/5. All you have to do is put the y number over the x number and you get the right answer. That's how easy that is to get, is you put the y number over the x number. Not b over a every time, but y over x. So this will be y minus 4 equals 4/5 with a plus or minus on it because it's got a positive and a negative slant, x minus 1. And again, that plus or minus is because we have two asymptote lines. One has negative downhill slope and one diagonal had positive uphill slope. So that's why it's plus or minus. And I put the point in by making them the opposite the same way as I took them out, because those two parentheses are based on the original problem's parentheses. Okay, so if this problem had started with a y, my problem would have been turned up and down. Does that make sense? And with my parabola, let's see, go back to that one. If my parabola had had a y here, then I would have counted up 1. If it had been -4, I would have counted in a negative direction based on what variable's next to it. So that's important to know, because when C is negative, you count left or down depending on if you're next X or Y. All right. What do you think?
So that's it. You don't have to worry about finding everything. You just have y minus 4.
We leave it in that format because it fits the center format. We don't have to distribute and move it over and make it y equals, which is nice, because we can still see the center in that formula. Yes, that was a good question. No, I didn't. I didn't do anything else to it. All right, we good? We getting a little bit of idea over here? All right.
It's coming back.
It's coming back, but you need a little practice. Now, aren't you glad that I'm not doing today? I could continue, and I could take these formulas and show you how to complete the square and then do all that. Wouldn't it be nice to practice that before we do the completing the square work?
Yeah, because when we was going over it, I was like, I do not remember.
Right, we need to know how to get all this information before we can do the complete square part. All right. So you have the rest of this worksheet to do for homework.